Hey, this is Mr. Mola with lesson 4-2, writing equations in point-slope form. So I really like point-slope form. This is one of those things where we talk about slope-intercept form a lot, but as a teacher and as an adult, I much rather prefer point-slope form. I think it's easier to see and easier to write. And plus, it kind of gets you to your answer a little faster, I think. So here on A and B, they give us a dot right here, so a starting point, and then they tell us our slope. So they want us to write the equation for the line. So we know it's going to be y equals 1/2 x. We just need to figure out the y-intercept here. So I'm going to go up 1, right 2, up 1, right 2. Okay, and then remember, positive 1 over 2 is also the same as negative 1 over negative 2. So I could also go down 1 and left 2, and down 1 and left 2, and down 1 and left 2, and I'd still get the same line there. So if we kind of connect these dots, we could see that it's crossing right in the middle there between 0 and 1. So our y-intercept is going to be right there at 1/2. All right, kind of the same thing here on B. So they give us our starting dot, and then our slope is negative 2 over 1. So I'm going to go down to right 1, down to right 1, down to right 1, down to right 1. Connect my line here. So they give us our dot. This one's at least a little nicer. It crosses at a whole number there. So y equals negative 2x, because that's what they gave me for the slope. And we figured out it's crossing at negative 2. But moving on to point slope form here. So here's point slope form. So I know it's going to look more complicated, that I will admit, but I think in the long run this is way better than slope-intercept form. So point slope form is y minus y1 equals, and then m, and then parentheses x minus x1. So this y here is always going to stay a y. That's never going to change. Same thing with this x here. That's always going to stay an x. That's never going to change. The y1 is the y coordinate of the point it's passing through. The x1 is going to change to a number as well. That's the x point that the line is passing through. M is our slope. That doesn't change. And then we got to do some math there to put it into y equals form or slope-intercept form. So this first couple problems just have us practicing it. So let me rewrite it up here at the top for us. So no math on these first 6. They just want us to practice writing it. So like if I look at number 1 here, they tell me the x is negative 2 and the y is 1. So remember, the y1 is going to change. So instead of y minus y1, I'm going to put y minus 1. The m they tell me is negative 3, so I'm going to put equals negative 3. And then the x they told me is negative 2. So minus a negative 2, which if you remember, minus a negative 2 really just changes to a plus. So this is all they want us to do on the first couple problems. Just write it out, so no math required. All right, if I look at number 2 here, same thing. So y, I'll change colors here. So y minus the y they give me here is 5, so minus 5 equals the m they give me is 2. Then parentheses x minus the x they give me is 3. So that's all they want us to do is just write those out. All right, careful on a problem like number 3 because of these negatives. It can be a little tricky. So y minus a negative 2 really turns into plus 2. So y plus 2. Our slope is negative 1. And then x minus a negative 1, same thing, minus a negative, just is going to turn into a plus. Okay, so first couple problems, they just want us to write it out. No math required there. Same thing on 4, 5, and 6. All right, 7, 8, 9, okay, and 10, 11, 12, I guess as well. They want us to write it in slope-intercept form. So nice thing about these problems are, since they're a graph, they give us the y-intercept. So I can tell already where the y-intercept is on these problems. It's where it's crossing the y line. So the thing they don't give us is the slope. So we got to do some math to figure out the slope. So remember, we have 2 ways we could figure out the slope that we learned last section. We can either count rise over run, or we can subtract. Since we have a graph here, I think it's easier just to count our rise over our run. So like from this dot, I'm going to go up 1, up 2, up 3, up 4. and then to the right 1 to the right 2. So 4 over 2 can be simplified to just 2. So y equals 2x. And then the y-intercept we pointed out before with the purple is negative 4. So my equation is y equals 2x minus 4. Okay. Same thing here. Y equals, and then let's count our slope here. So it looks like I'm going to go down 1, down 2, down 3. To the right 1, to the right 2, to the right 3. So down 3 over 3 can get simplified just as negative 1. And it looks like our y-intercept is crossing at 3. So y equals negative 1x or negative x plus 3. All right, number 9 here. So y equals, so it looks like I'm going to go up 1. Oh, I'm sorry. I thought that was a dot there. It's not. It's my dot. I mean, we could go from that dot as well, but. So I'm going to go up 1, up 2, over 1, over 2, over 3, over 4. So 2 over 4 can get simplified as 1/2. And then it looks like our y-intercept is at negative 2 there. Okay. Here at number 10, got a long way to count here. So it looks like we're going down 1, down 2. And then over 1, over 2, over 3, over 4, over 5, over 6, over 7, over 8. So 2 over 8, or negative 2 over 8 is the same as 1/4. And our y-intercept is 0, so we could put a plus 0. You don't have to. All right, here, 11, something I want you to be aware of is the scale it uses here. So we'll see here, this first dot, it says is at 2. Same thing here. This is at negative 2. This is at negative 4. So be careful here on one of these. Some people might want to say the y-intercept is negative 3, but it's actually negative 6 because the scale changes there. So you can see each of these is 2 on the y scale, not 1. And then we got to count our slope. Oh, man. So we're going from negative 9. So negative 7, negative 5, negative 3. So that's really then 6, and then over 1 over 2. So 6 over 2 is the same as 3. So y equals 3x minus 6. All right. And then the next couple of problems, 13 through 18. So this is where it gets a little more difficult because now they're not giving us the slope and they're not giving us the y-intercept. So we're going to have to do some math to figure out both. So we've already done math before where we figured out the slope. We did that last section. Remember, we used y2 minus y1 over x2 minus x1. Except with those problems, they gave us the y-intercept. Here, they're not giving us the y-intercept. So then we have to do another step of math to figure out what the y-intercept is. So first, let's figure out the slope. If you remember, this is our x, this is our y. This is our x, this is our y. So if I'm going to subtract my y's, I'm going to do 4 minus negative 1. And then I subtract my x's, and I'm going to get negative 2 minus a negative 3. So 4 minus a negative 1 turns into 5. Negative 2 minus a negative 3 turns into 1. So I figured out my slope is 5. So y equals 5x. The thing I don't know is my y-intercept. So now we need to do some more math. It's kind of what we did on the first set of problems. I'm going to plug that in to my point slope form and see if we can figure out what it is. The wonderful thing about point slope form is I can pick any one of these x's and y's and I'm still going to get the same answer. And I'm going to do both of them for this first one to kind of show you that. So let's do this first one with this x and y. Okay, so y minus my y they give me here is 1. So minus minus turns into a positive 1. We found out the slope was 5, so that's why we need to do the slope first. And then the x is a negative 3. So minus a negative 3 turns into a plus 3. Okay, so there it is in point slope form, but it wants it in slope intercept form. So here's your 2 steps of math. First step is to distribute. So after I distribute that 5, I get 5 times x is 5x. 5 times 3 is 15. Oops. Okay, there's your first step. Second step is to subtract 1 from both sides. So then once I subtract 1, I get y equals 5x. 15 minus 1 is 14. So I figured out my y-intercept is 14 there. So kind of two different problems that we're solving there when they want us to write in an equation like that. First, we have to do this part in black where I figured out the slope. Then we have to do the part in red where I figured out the y-intercept. Okay. Like I said before, you can pick either point, and I'm going to show you. So here in red, we picked the -3 and -1. I'm going to do the point in blue just to show you how it's going to be the same. So same thing, y plus the x that I'm picking there. Here's my x, here's my y. So the y there is 4. So y minus 4 equals, slope is still 5. That didn't change because we're still doing number 13. And then x minus a -2 turns into a +2. Okay. And then same two steps. I need to distribute my 5 there. So 5 times x is 5x. 5 times 2 is 10. And now it's a -4 over here, so I need to add 4. So I still get y equals 5x plus 14. So no matter what, I'm still going to get y equals 5x plus 14. It's not going to change based on those. So I'm going to do one more. I'm going to do it on a new page since I kind of ran out of room here. So I'm going to do number 14 here. So this was 14. So here's my x, here's my y, here's my x, here's my y. Okay, so first thing I need to do is figure out the slope. So I'm going to subtract my y's, 7 minus 1, and then 1 minus -2. So 7 minus 1 is 6. 1 minus a -2 turns into 1 plus 2, so that's 3. So my slope is 2. Okay, now that I figured out my slope is 2, I need to figure out my y-intercept. Okay, I don't really want to deal with negative numbers, so I'm going to pick these 2 points to do. Again, it doesn't matter which points you pick, it's still going to end up the same. So y minus 7, my slope is 2, x minus 1. So 2 times x, 2 times 1. So first step is to distribute. And second step is to do the math here. So it's a -7. So I'm going to end up adding 7. So y equals 2x plus 5 is going to be my final answer. Okay, so again, first thing you need to do is the purple part where we figured out the slope. Second part you need to do is the part in black ink where you need to figure out what the y-intercept is. So a little bit longer on those two problems. And then 19 and 20, they want to see if the equation can, or if we can make an equation for this. So pretty much asking if it's linear. And we're lucky here, they gave us the y-intercept. 0, -35 for this one, 0, 8 for this one. Remember, the y-intercept is always when it crosses 0. And so we just need to see if our slope is linear. So will the slope be the same both times? And if I see here, my x's are going up by 2, and my y's are going up by 50. So if I subtract my y's, I'm going to get 50. If I subtract my x's, I'm going to get 2. 50 over 2 is the same as 25. So my slope is 25. My y-intercept is -35. If I look at this one, however, my x's are still going up 2, but then my y's are changing here. So like from 8 to 62, well, that's going up 54. But from 18 to 8, that's going down 10. So this isn't going to have a consistent pattern. So this is not going to be a linear equation. So I can't write a linear equation if it's not linear. So we're just going to call that one nonlinear for that one. All right, and then the last one, Craig is driving at a constant speed of 60 miles per hour. So 60 miles per hour means he is driving there constantly, 60 per hour. If they're driving 3 hours, the odometer reads 265. Write the equation, write the linear equation d that represents a function after h hours. Okay, so here, if he's going 60 miles per hour, that's 60 plus 60 plus 60, which is 180. And it says 265, so that means I know it started with 85 miles on the odometer. So then I plug in 7 here for there. If it wants to know after 7 hours, 60 times 7 is 420, plus 85 is 505. So he would be 505 miles after 7 hours.